Hi there. I'm Craig Stark, and I'm a member of the Alzheimer's Disease Research Center at the UCI Mind, and I'm also the Biomarker Core Leader in our new ADRC grant. I want to take this opportunity to just tell you a little bit about the kinds of things that have been going on at the ADRC in terms of biomarkers, and also really what's coming down the pike. The first thing that we've started to really do in our new biomarker core here is to pull together all of that incredible neuroimaging and CSF data that you've really helped us collect over the years. We have hundreds and hundreds of scans that are all now getting analyzed with a modern pipeline and results made available to ADRC researchers to really try to see what can we use inside of those brain scans to help us understand how disease is progressing, who might be at risk initially, and to really try to separate this out from typical aging. So we're getting all of that going, and we're also going to be tying this in with data from a new piece of equipment that we've been able to procure, a Roche Alexis. What this does is it lets us have advanced analyses of your cerebrospinal fluid, or CSF, that can also be done in an incredibly repeatable, accurate, reliable way, and to a standard in a way that can be really shared with other ADRCs and other researchers across the world here. This is going to give us the most sensitive, most efficient, and least invasive kinds of biomarkers for Alzheimer's disease, for this early detection. And as I said, this is going to be something that we can use to really integrate with other ADRCs across the nation to pool our efforts and really try to get a best understanding as to how this disease is actually operating here. In addition, though, we're not just taking all of our existing data and reanalyzing it here. We're really trying to push boundaries in developing new biomarkers for Alzheimer's disease. In particular, we're really excited by an award from the Gunther Foundation that's given us the ability to get a new kind of look into, a new glimpse, a new window into the brain of Alzheimer's disease, something that we've never had before. It's letting us get some new specialized equipment for our MRI scanners, both our human and our small animal MRI scanners, that lets us get a window into brain metabolism. Because researchers have thought for a long time that there's a real brain metabolic component to Alzheimer's disease, but honestly, it's been pretty poorly understood and not that heavily investigated. And one of the real reasons is because we haven't had the ability to actually look non-invasively into the human brain and get a good picture of this metabolism. And that's what this award is going to let us do. We're getting specialized equipment that not only lets us look MRI scans when you lie inside the scanner. What we're really doing is we're listening to the hydrogen atoms inside your body. And you're made of a lot of water, so you have a lot of hydrogen, H2O there. But this metabolic kind of component, we can only image by looking at other things like carbon and phosphorus. And this award lets us actually get that equipment and lets us then use this to really try to understand, can this be a novel biomarker for Alzheimer's disease? Now, it's a heavy lift, and it's certainly going to take us a lot of time. It's not made any easier by our current situation here, but it's something that, as you can see, we're really excited to be able to do. And then finally, we're also working on how to develop the best way to test your memory so that we might have a cognitive test that would be able to quickly and efficiently identify people who need further testing. This is part of our new ADRC award, and it's a test that my lab has been working on for, well over a decade or so now. And it's also part of a grant that Josh Grill and I were recently awarded from the NIA. And some of you may have seen this task. We show you pictures of objects, and some of them are devilishly similar to objects that we've shown you before. And it really tests your memory for those details. Now, research in my lab has shown this is very sensitive to functioning of a structure called the hippocampus. It's critically dependent in memory, that's affected by aging, and that is also sort of ground zero, the hippocampal area there for Alzheimer's disease. Now, we've shown how it can pick up these kinds of things, and in fact, actually in this large A4 trial, a $350 million Alzheimer's trial that you may have heard of, this little memory test of ours and one other there were the only ones that were able to separate out people who didn't have any real outward signs of Alzheimer's disease, but who were in fact actually carrying amyloid in the brain that you might detect with PET. And this little memory test here was able to actually do that. So sensitive as the PET test, but is able to actually get a nice image onto that. So now the project that we're working on here, it's something that's really exciting for us here because we can maybe actually have a quick, efficient behavioral test to serve as a kind of screening. And that's what this project is really all about. It's being supported by the ADRC and the Consent to Contact or C2C database. And we're really trying to come up with a simple, efficient way of being able to actually get at that. Something that down the road you may do in a doctor's office on an iPad, or you may be able to do yourself at home. We're going to need your help a whole bunch in letting us get a lot more data on this and really make this a successful project. So there's a lot going on, a lot that's building on all that you've done for the ADRC in the past, and a lot that's going to be needing your help in the future. And for that, I'd like to say thank you and hope that in someday soon, I get to say that in person. But until then, take care, stay safe, and know that a heck of a lot is still going on here and that we certainly need your support. Thank you.